Alright, for study guide homework 1023, I want you to take your blank study guide, copy all of these problems and work into it, and then to show me that you listen, write down the words that will quickly appear and disappear to show me that you were listening. So again, take the time to pause the video to write these numbers and choices, maybe try the problem out, and then watch the video to check your work. So here we go. This first set, 6, 28, 54, 162. First term, if it's not listed, we want you to see that that 6 is the first term, not the 0 term. I'm timesing or multiplying everything by 3, and I can again check that by taking the previous term divided by the one before it to see what that number is. 18 divided by 6 is 3, 54 divided by 18 is 3. So that checks that I'm timesing by 3 to the right. To the left, dividing by 3, but remember we don't show dividing by 3. We show dividing by 3 as multiplying by the reciprocal, or multiplying by 1/3. So that 6 times 1/3 gives me 2. And trying to show that 6, the whole number, times 1/3, 6 over 1, multiply straight across, gives me 6 over 3, which is 2. Again, show all this work on your packet. So I'd like you to write both forms before you start looking at these choices. So the first one, using the 0 term 2 times the common ratio 3 to the x power, or just the singular variable power, or the first term, 6 times that 3 to the x minus 1 power. Write these down before you look at these choices. So you can see this first one is bad because it has the wrong common ratio, has a 2 there instead of a 3. This one is bad because the way that's set up, this should be n minus 1. This one is bad because the way that's set up should be just plain old n, not n minus 1. This one is good. It's got the 0 term, the common ratio, and a single variable power, the n. So it matches that one perfect. And again, look for those words that show up and quickly disappear. Alright, number 2. This one I'm giving you the recursive pattern, telling you the first term is 5, telling you that you're timesing that and every other number by 8. So taking that 5 times 8, whatever that number times 8, whatever that number times 8, continue that pattern. Make sure you give me all 4 numbers. 5 times 8 is 40. 40 times 8 is 320. 320 times 8 gives me 2,560. And then that times 8 gives me 20,480. And again, make sure you're giving me the next 4 numbers. Don't stop short. Don't stop at 2560. That's only the next 3. Give me all 4 next terms. There they are right there for this problem. Alright, number 3. This one, again, take the time to write these numbers in there. Give it a try and then start the video. But this one, going up by 4 on y, going up by 2 on x. Again, back to this problem, going up by 4 on the y-axis, going up by 6 on this last term, going up by 2 on the x-axis, going up by 2, going up by 2. This last term is going up by 3. So again, to find the slope, the first thing I need, the rate of change, the m or the d. I'm using the change in y over the change in x. I could use any of these pairs. I could use 6 divided by 3. I could do 4 divided by 2. Any of these will give me the same slope. So 6 divided by 3, I should say, or 4 divided by 2, all give me a slope of 2. And again, change that to a 3 right there. Take that slope, put it where m is. Going to go right here in that slope-intercept form. Write it with that 2 in front of x plus b. Pick any coordinate to plug in. Any coordinate, negative 1, 1, 3, 9. I'm going to use 1, 5. That 1 is going to go where the x is, and that 5 is going to go right there where that y is. So this one gives me, when I replace that, gives me 5 equals 2 times 1 plus b. Solving that algebraically gives me 5 equals 2 plus b. Take away 2 on both sides, gives me the y-intercept is 3. B equals 3. And then when I write that in my final equation, f of x equals that slope number in front of x, 2x, plus that y-intercept, which is down here, which is 3. So that is my final answer, 2x plus 3. All right, for number 4, again, fill in that equation, fill in these numbers in your table. The number in front of x is the monthly rent, how much you're paying each month. That 800 number is the deposit. So if I'm asking you the deposit fee is 800, that is true. That is the number all by itself. That is the one-time deposit. That would be true. This one, deposit fee 1400, that would be false. That's the rent. If I'm saying that's the rent, that makes that true. And then if I plug in 1 here, 1400 plus 800 will give me 2200. That is a false statement right there. All right, number 5. This one says which function or which pattern is an exponential equation. That's timesing. First one is adding by 3, linear. Second one is timesing by 3 all the way through, which makes that exponential. The third one and fourth, I believe, are neither, because you're adding by 3 right here, adding 4 right here, adding 5 right here. That's a neither, one of those neither exponential or linear. And then this bottom one looks like you're timesing by 3, timesing by 2, or adding 4, adding 6, adding 8. Another neither exponential or linear. So again, this is the exponential one I'm looking for, 1, 3, 9, 27. All right, number 6. For number 6, 7, and 8, I'm giving you this pattern, negative 86 minus 69. I could see that it's going down. The only thing that makes these negative numbers go down is if you're adding a positive number to them. So again, if you take 86 minus 69, just those two plain numbers, you'll see that it's going down by 17. So negative 86 plus 17 gives me negative 69, plus 17 gives me negative 52. If I'm backtracking to the zero term, taking away 17, so negative 86 subtracting 17 more gives me a whole bunch of negatives, gives me negative 103. So if I'm asking arithmetic, for sure arithmetic, the explicit forms would be f of x equals the common ratio number, or the common difference, 17, or the slope x, minus or plus the zero term, 103. Or I could write that as f of x equals 17, and then in parentheses x minus 1 minus the first term, which is 86. The recursive function would be f of x equals f of x minus 1 plus 17. Again, these are both forms of explicit for my arithmetic sequence, and here is my recursive. All right, number 9. Again, this one has two coordinates you're trying to find the slope for, so 0, 600, 6, 750. For Math 1, this test problem will not be on your benchmark, so it's up to you if you want to write this work. But that will be 750 minus 600 divided by 6 minus 0, or the change in y divided by the change in x. So 750 minus 600 divided by 6 minus 0. No need to change the units here. It's dollars per hour already. Gives me $150 for every 6 hours. Make that into its unit rate, or over 1 hour. Gives me $25 for every 1 hour. Don't put 25 charges, $25 per hour. Okay, number 10, 11, 12. Remember, this one is number 10. So for this one, I can see it's geometric. If I want to see what I'm dividing by here, or timesing by the fraction, 248 divided by 124 is one way to see I'm getting divided down by 2. But remember, we don't write dividing by 2. We'll write that as timesing 1/2. Another check, 124 divided by 62 is 2. So yes, I'm dividing by 2, but we write that as timesing 1/2. Timesing 1/2. Going to the left, I'm timesing by the whole number 2. So 248 times 2 gives me 496. So my recursive function would be f of x equals f of x minus 1 for the 10th problem right here. That's number 10. Times 1/2. This definitely is a geometric sequence. And then my explicit forms, I would concentrate on just one. Don't try to write both, just write one. But the first one would be the 0 term, 496, times 1/2 to the x power. Or I could use 248 times 1/2 to the x minus 1 power. Any of those forms would work. Pick one. All right, 13th problem. Here it comes. For this one, again, Math 1, this problem will not be on the benchmark. It's optional if you want to do this. Math 1 honors for sure. So going up, my miles going up by 2. Here, time going up by 5. Here, going up by 20. But here is going up by 8. These will give you the same ratio. So 8 over 20, or 2 over 5, or any of the other change in y over change in x will all give you the same ratio for this problem. So 8 over 20, or 2 over 5, which I'm going to use because they're smaller numbers. That would be 2 miles over 5 minutes. And if I multiply that by 60 miles per hour, and again, 60 minutes for every 1 hour, timesing straight across, my minutes units will cancel. 2 times that 60 gives me 120 miles over 5 hours, because there's only hours units now, and dividing that down to its unit rate gives me 24 miles for every 1 hour. All right, 14. Again, take the time to write these problems in. I could see any percent exponential. Anytime I see a percent in there, exponential. The second one, I need to see what these rates are. So 80 divided by 2 is $40 per hour. 120 divided by 4 is $30 per hour. I could see these are not the same rate, so this one is one of those neither ones, neither. Alright, problem 3. I do not see a percent, 1,000 each year. That is linear. Number 4, first hour 5, going up by 4 for the second hour to get 9, and then from 9 to 14 going up by 5, again a different rate, just like number 2. This one is a neither one. And then number 5, any percent automatic exponential. You're going to be clicking and dragging these into the boxes tomorrow. Click and drag. So for this one though, linear is going to be number 3. My two exponentials are 1 and 5. And my neithers are 2 and 4. Alright, 15. This one, again, find the common ratio, write both forms of explicit. Find that common ratio by taking 212 divided by the 0 term 200. Could have got that same answer by dividing 224.72 by 212. But either way, I divide those out, gives me 1.06. 200 is the 0 term. First term is 212. So again, take the time to write both forms before you look at these choices. F of x equals the 0 term 200 times 1.06 to the x power, or f of x equals the first term 212 times 1.06 to the x minus 1 power. I can see that this first one here matches perfect. The second one is close, but it has the wrong R number. Third one's close, has the wrong R number. Fourth one is good, except instead of the first term here, it has the second term listed instead of the 212 right there, which would have made that correct. And back to that, sorry about that. So again, that is 212. Not sure why I erased that right there. And I can see that this is not the first term, which makes that one bad. Alright, last set. So again, take the time to write these choices. This is one box right here. I have 5 right here. And then looks like 5, 6, 7, 8, 9, 9. So it looks like I'm going up by 4 each time. Makes it arithmetic. If design's not listed, that's design 1. Subtracting by 4 to the left, adding by 4 to the right. 1 take away 4 gives me -3, which is my y-intercept or my 0 term, -3. I'm going to write all 3 forms before I check and see which one is the bad one there. So my recursive form is f of x minus 1 plus 4, which I could see right here. My two explicits are f of x equals that 4 times x minus 3, and my other explicit is that same 4 times x minus 1 plus 1 right there. And I can see all of these except for this one with a 5 in front of its x are bad. But this one right here is the same as that, just backwards. This one has the correct 0 term. This one has a 5. This is the recursive. The only bad one is this one with a different number in front of x or a different recursive form number. That one is bad. To find the 25th term, I'm going to use the 4x minus 3, the most common one, the y-intercept one, the zero term one. So 4x minus 3, I'm going to plug in 25 for x. This right here just shows me what I'm plugging in. Over here with this 4 times 25, that's where I'm actually doing work. So 4 times 25 gives me 100 minus 3 gives me the 25th term is 97. Make sure you're writing it in that box right there tomorrow. 97 white squares. Good luck. Finish your packet, write down those words, show me on your slides, or turn in tomorrow. Good luck.